This is a short screencast on plate movement and volcanoes. Here is a section of the Earth's crust. What we have is the Earth's crust at this very thin layer along the top, and below that the outer layer of the mantle. Together this part is called the lithosphere. Down here is the core. The mantle at the bottom here is much hotter than the rock at the top and less dense. So mantle rock rises very slowly, and when it reaches the surface it will spread out in both directions. The rock will then cool, the mantle will then cool and fall back down to the bottom again as it cools, and you end up getting a circular current of motion. At the top, this movement drags the top plates from one side to the other side, and it looks something like here. We see the mantle currents rising and spreading at the surface, and they are dragging the plates in either direction, and that results in the movement of the continents as we've discussed in lessons. Where the plates are moving to the side, oceanic plates meeting continental plates, the oceanic plates will subduct under the continental plates, and you get magma generation at this point, which can result in volcanoes. And I'm going to talk to you a little bit about volcanic rock. So lava is liquid rock. When it cools, it will form crystals, and the crystals grow together and interlock. If you allow lava or magma to cool slowly, you form big crystals. If it cools quickly, it only forms small crystals. Now, the minerals in the rock can vary. Here are some examples: feldspar, quartz, hornblende, agate, and plagioclase. Feldspar is the pinky one here. Quartz is the whitish one. It's actually clear. And hornblende is one of the darker ones. Here's a nice smooth cut polished surface, and here's just a rough naturally worn surface. These rocks are iron rich. This is basalt. The magma came to the surface and cooled quickly, therefore the crystals are small. This is gabbro. The liquid rock stayed under the ground and cooled very slowly, so it has large crystals. This is granite, which is silica rich. It's formed under the ground, cooled under the ground, so it has large crystals. Rhyolite has the same mineral content but cooled on the surface, and therefore this has smaller crystals. Silica rich magma is much thicker than iron rich, so leads to much more explosive volcanoes, much more likely to trap carbon dioxide or other gases inside the volcano and then explode with a sudden force.